You're watching New News. Today's weird science, big impact story. Parasitic worms using static electricity like a tractor beam. Okay, picture this. Insects build up electric charge just by flying, rubbing against plants, even dry air. Scientists found that tiny parasitic nematodes can get pulled onto those charged insects, no jump required, thanks to static forces. It's like nature's version of a sci-fi grabber. Here's the wild part. These worms don't need to chase. When an insect buzzes by, its electric field reaches out and yanks the worm through the air. We're talking millimeter-scale creatures taking millimeter to centimeter leaps, without muscles doing the work. The field does the heavy lifting. Researchers tested this with charged insect wings and surfaces, and they watched the nematodes get snapped up from a distance. The effect is strong enough to overcome gravity and air resistance at that tiny scale. And once they're aboard, the nematodes do what nematodes do: infect the host. Why does this matter? Because these particular nematodes are already used in agriculture to control pests. If static electricity helps them board bugs faster and more reliably, farmers might need fewer chemical pesticides. Better targeting, less spray, greener fields. Also, nature is giving us a blueprint. Micro-robots could use ambient electric fields to hitch rides. Drug delivery particles could use ambient electric fields to dock with targets. Think smart dust that doesn't waste battery power, just rides the field. Let's break down the physics in plain English. Charged insects create an electric field around their bodies. Neutral objects nearby, like nematodes, become slightly polarized, one side a bit negative, the other a bit positive. That imbalance makes a net force that pulls the worm toward the insect. No magic, no magnets. Just Coulomb's law doing its thing. Limitations? Humidity can bleed away charge, so the effect may drop in damp conditions. Not every pest or environment is the same, so field results will vary. And tractor beam is a metaphor. It's still electrostatics, not a Star Trek laser. Detailed analysis. This discovery reframes host-parasite encounters at microscales, where electrostatic forces rival or beat gravity. It explains how nematodes close the last gap to a moving target, boosting infection rates beyond random contact. In practice, that could optimize timing for releasing biocontrol nematodes. Dry periods might be best, breezy periods might be best. It also suggests breeding worms to enhance polarization and stickiness, or formulating worms and carriers to enhance polarization and stickiness under typical field charges. Finally, it challenges models of insect ecology that ignore ambient charge, opening new research on pollinators, pests, and plant surfaces. What do you think? Is static-driven hitchhiking the next big edge in pest control, or just cool lab physics? Drop your take in the comments. If you enjoyed this, like, comment, and subscribe for more new news. Thanks for watching.